Okay. Now I will give you something example about the research results in our academy. First, I want to say the Institute of Medical Research, China Academy of Sciences, led by the group led by Professor Luke. They have worked in the nanocrystalline materials for many years. They have published a series of papers in the science talking about the copper, nanocoppers. This figure shows you the nanostructured coppers can be elongated to more than 50 times without the breaking in the room temperature. So this feature is very useful for advancing the processing technology of metals and alloy. And they have published series of papers about the twins structure and something the others. So talking about the nanostructure manipulation, so the Professor Ho from USTC, they published a paper in the Science several years ago. They used the SM tip to modulate the single items, and you can see that this is let me see, it's a copper cytosine, the single molecule they are studying. The US team to cut out the several items from this molecule, so you can change the molecular shape. But here show you the magnetic properties. Here, original like this, they use a tip cut off some items. They cut this part, become to the magnetic properties. This magnetic image of this molecule, like this. Finally, they cut off 4 of the groups. They change. I think this is the first time the physical properties of the single molecule can be altered and controlled by use of selective chemical reaction just in a single molecule. Also, Professor Bob in the Darling Institute of Chemical Physics, China Academy of Sciences, published paper in the Science talking about the nanoscale interface confined catalytic systems. So that institute, many groups working in the catalysis, they developed this new concept. Also, there are some also papers published by CTU, Professor Sultan Li, talking about the nano fibers, and here is also published by Nature by Professor Sung Cook and Yung Zhang in Nature the last year by CTU. So there are also many more achievements, such as in the Institute of Chemistry of Academy, Professor Jiang, they published a series of papers talking about the nano research learning from nature, bionics, talking about how to make the special use of the nano materials. I will give you some example later on. The Xiamen University and the other university also study the different area in the nanoscience technology, such as in Xiamen University, they developed a new approach to enhance Raman spectroscopy by using nanomaterials. I think China has advanced basic research in the field together with the world, and the more important value for nano progress lies in its application to real-world challenges. So in this regard, China has also achieved some success. So I give you some example. So I think just one example. A group at the KS Institute of Chemistry developed a nanomaterials-based green printing plate technology. It has a big potential to bring the revolutionary changes to a printing industry. So I show you, when we want to print something like the newspapers, magazines, the books, first you have to make the plate. Then you print the 1,000, 10,000 newspapers. So the procedure is something like this. You first input the pictures and text information to computer. Then from computer to laser phototype setting machine, and to photosensitive to produce photosensitive film, just like the film camera, right? So this part is called the 激光照排 the laser phototyping setting the machine. Then you have in the dark room to expose, develop this chemical treatment process. Then you get film. Then you get PS plate. Then you burning plate. Then you get second the develop exposure, develop, fix. The second the chemical treatment process. Then get a final plate, which can be used to produce 10,000 the newspaper, books, something like that. This we call the laser the phototypesetting system is 2 steps photographic development. So now we have the CTP in the world, and it is international mainstream technology. They just use the 1 step, the photographic development, something like this. You put a picture, text to computer, to CTP equipment, get CTP plate. You just need one, the photographic development, expose, develop, fix, get final plate. Yeah, but the problem with those 2 kind of technologies we are currently used in the world is the photographic imaging. We need the process in the darkness. Okay, then they need the chemical development, cause the liquid waste discharge, and the other things is the pre-coating the waste resources. We used to use silver to get the film. Just when you print something like my name, you can say like this. For example, if you want to print this one, you put to coating whole the plate with the silver, something like that. Okay, so when you export just these 3 words, then rest of them should wash out, then waste all the silver on coating. So usually when we count, only about 20 to 30% of total coating remain after the development. So that waste all the materials. That's a problem for all the technologies currently used in the world. Everything used like this. So we developed the new technology for this. So we just input a picture, text information to computer, then direct get a printing plate. We do not need any chemical treatment. So no need to avoid the light, no pollution, is low cost and recoverable. This is a new technology using nano materials. So we can say something like that. The technology we are currently using, something like the film camera. Now we change it to the digital camera. Just something like that. Yeah. The nanomaterials based this green printing plate technology is kind of innovation. So we now need pre-coating process. All process is green. We use a nanoparticle covered by the polymer layer to surface modification, then and also the key technologies include control the nano macro structures of the superhydrophilic plate, because the plate is superhydrophilic and modulate the some chemical properties. Then you get when the plate is hydrophilic, so when you print something you want to leave there, how to say that? It's very something like the Chinese stamps, like that. So something due to the different chemical, the super hydrophobic is a different. Then you can get a different printing, something like that. Yeah. So use this technology, we have already produced some newspapers, the calendars, magazines. We have developed 3 kind of the machine to already used in some the news agencies in China. I think it's very important the new technology. So there are several institutes in our academy. They have already developed many other nanostructured materials and technologies, even for the lithium-ion batteries, for any other things. Yeah. So China attaches importance to the nano standardization. I think this is very important. When you want to make the commercial trade or academic exchange, if you do not have the standard, that's something that cause some problems. So we, in the 2005, we have set up a special committee we call the China National Nanotechnology Standardization Technology Committee. We have published 32 national standards in the nanoscience technology, and recommended 3 national standards as international ones. 2 ISO standards proposed by China have been published, and 6 more are being internationally reviewed. So we want to participate in the international standardization in this field. Okay, now I just want